the mission, I should say, and how you see it differentiates by either aircraft or business model from some other worthy eVTOL UAM competitors.
Great, thanks for having us, Adam, and pleasure to share more about Lilium today. So on myself, I'm an aerospace engineer by training and co-founded Lilium in 2015 together with my 3 co-founders and fellow engineers in Munich. Lilium's mission from the beginning was to create a sustainable and accessible mode of high-speed regional transportation. And we have a unique approach to achieve this, which we believe is a breakthrough opportunity. We are developing an all-electric vertical takeoff and landing jet. It's the only vertical takeoff and landing jet globally in development right now. But we're also developing the complete ecosystem around that jet to do the regional services based on these airplanes. What will Lilium's impact on the planet and people's lives be? We think that the speed at which people moved over the last 50 years did not really improve. Transportation infrastructure is broken. So we believe the electrification of aviation is both urgent and also inevitable. We've seen startups focused on sustainability have disrupted the automotive industry, and we expect something similar to happen in aviation in the next couple of years. And we think that Lilium is best placed to capitalize on this opportunity and drive a change towards all-electric regional aviation. So how is our approach unique? We are not creating an on-demand air taxi service with 1 or 2 passengers per trip. Instead of that, our business model is to focus on a regional shuttle service with on-demand flights and longer routes. And this enables us to bring more people on board and reduce the cost per flights and get better economics and democratize this type of service, as is our mission. You have seen for sure eVTOL aircraft using propellers like a helicopter. We have done something completely different. It's a vertical takeoff and landing jet based on our proprietary technology, the ducted electric vector thrust technology. And that's not the easiest route to go from an engineering point of view, but it provides us with crucial economic advantages. And these are basically three economic advantages. The first one is that our technology allows for higher capacity aircraft, bigger airplanes with more passenger seats that allow us to move people at scale and lower cost. The second advantage is a high performance on speed and range. And the third advantage is the lowest noise among all the technologies in the market. So if you compare our airplane to a propeller eVTOL, it generates roughly a 5 times smaller noise footprint during takeoff and landing on the ground. And this is the key enabler for market acceptance and for opening and making the eVTOL market a reality in general. So in a nutshell, the technology means we will be able to have market-leading economics, but also have a larger addressable market because we can access more places in cities. We have a quite ambitious timeline to launch commercial operations in 2024. So why are we so confident? There's a couple of reasons for that, but the main reason is the amazing team we have brought together. Lilium is a wonderful mix between German engineering experience and expertise on the one side, and the Silicon Valley mindset and execution on the other side. Our leadership team, for example, have delivered some of the most successful and complex aircraft in aviation history, ranging from the Airbus A320, the A350, the A380, to fighter jets like the Eurofighter and the Harrier jet, as well as the Gulfstream G650. The former CEO of Airbus, Tom Enders, is on our board, bringing excellent experience on building airliners and aircraft OEMs to me and the management team. We have tested our technologies over 4 generations of aircraft in flight testing between 2016 and today. We had roughly 5 years of technology development done by now, and we are supported by a roster of world-class suppliers. We're only partnering with tier 1 aerospace suppliers on the supply chain side because we want to capitalize on their quality and experience and their aerospace expertise of the past. And we have a diverse set of investors, long-term investors such as Bailey Gifford and strategic investors such as Palantir or Tencent from China. Let me maybe stop here, Adam, and see what questions you have prepared for us.
No, it's a great pedigree of the relationships, and you've got Munich operations, and then we'll talk about Orlando as well, which sounds pretty exciting. And I hear from people in Orlando, they're very excited about seeing Lilium come to town and develop this kind of transportation community of the future. But back to that design again, because it really stands out. I mean, Daniel, it's so radical, the ducted electric vector thrust. You highlighted the reasons: capacity, scale, performance, noise. I mean, those are all individually very, very important at different phases of operation. Noise, I find, gets really underestimated. Where has this technology been commercialized in any scale? What other applications have we seen that in? I'm not aware of a Dyson vacuum cleaner jet, but it really is a jet. Like, how radical and how much risk are you taking to achieve those very important objectives?
So in a nutshell, every airliner and business jet is using jet engines, and they do so for the same reason. So the difference is basically comparing a turboprop aircraft to a jet engine-based airplane. The difference with these quote-unquote old jet engines is that they are driven by a gas turbine in the center, which is burning kerosene, and the gas turbine drives the fan in the front, whereas we have replaced the gas turbine with an electric motor, which is driving the fan in the front. So the overall principle is actually very old, and it's being used in 95% of all commercial aviation for the same advantages, like lower noise and lower vibration in the cabin that we see as well.
But where else is electric, I guess specifically the electric jet technology, has that been commercialized? And tell us a bit more about the IP there, because That sounds special.
We are the first company who have shown an electric jet in flight, and who have currently, to our knowledge, an electric jet engine in the certification process. But you have to expect that there's a lot more of this coming, because if you want to make an electric airliner, for example, you need electric jet engines.
Great.
So
Ravi, what do you have on that? I'd love to pass it to you, Ravi, on that, on going a little further on that technology from the airline lens.
Sure. So Daniel, kind of in operations itself, right? So apart from the noise, apart from the redundancy, in terms of cruising efficiency, in terms of the passenger experience, kind of does being a tilt wing aircraft give you benefits over being a tilt rotor aircraft?
Yes, it does. It gives you advantages in terms of lower vibration levels, and it gives you advantages in terms of lower noise levels in the cabin, in the cruise operation.
Got it. And kind of a question we get from a lot of industry folks is kind of have you made much progress on the proof of concept here? Kind of how many flight hours of testing have you done? Again, just given the kind of radical design here, I think the question people have is, it almost seems like one of those things where if you make it work, I mean, it looks like you have something really unique and differentiated. At the same time, can you make it work is the question.
Yeah, of course we can, and we've shown that. We've had a total of 4 generations of technology demonstrators in flight testing over the last couple of years. Most of them we've shown in public. We had 2 subscale demonstrators in the 3-4 meters class, and then we had a 2-seater which flew in 2017, and then we had a 5-seater which flew in 2019. And on these 4 models, in total, we've had a couple of hundred flight tests completed, which led us to the conclusion 2 years ago that we are ready to go into the commercialization, and we started the development of the 7-seat serial aircraft using the same technologies about 2 years ago.
Got it. And the last one from me on the aircraft, I pass on to you, Adam. Obviously, you guys have a pilot on board. At what point do you think you can make it autonomous? Do you want to make it autonomous?
Yes, one day we want to make it autonomous, and the aircraft is designed to be upgradable for autonomy in certain areas. But for autonomy, both EASA, the European, as well as FAA, the US regulators, have not yet published or converged on any regulation. We are in active conversations with both authorities on that. But in terms of timeline, investors should expect that it will take 3 to 4 years until there is a regulatory basis. And then you need another few years until you have developed your technology which matches the requirements, and until you have tested it and you will see it in service. And this was one of the reasons why we decided to go for the shuttle business model, because it basically means the numbers work from day one, because you have a pilot on board, but you can distribute the pilot cost over more passengers in the aircraft.
Daniel, just to confirm, is this a battery-powered aircraft, or does the electricity come from a fuel cell or a hybrid source? It's
an all-electric battery-powered airplane.
And so if I were to talk to the, one of the dozens or so of the distributed electric propulsion, more propeller-based or lift and propulsor-based designs, what would they say about your design? What are some of the trade-offs? Are there trade-offs in terms of cost, efficiency, or range that you have to surmount in order to achieve this sound and capacity benefit? Obviously, I'm not asking you to speak for them, but you must be familiar with the arguments. Why are more not trying this? What would they say?
Exactly. There's nothing that comes for free in engineering. So
right.
the main trade-off you are making of this technology is that it consumes more power at takeoff and landing. And that is per se not a problem. It means that for the overall mission, it doesn't make a bigger difference than 5%. But it means that you have to design a powertrain that is capable of providing these higher peaks of power for the takeoff and landing. And that makes it, from an engineering point of view, a harder nut to crack.
Great. So I believe you have 400 engineers on the presentation at the company. Tell us a bit more about your hiring, your build out of your operations between Europe and the US or other regions, as you take that German engineering in Munich and that Silicon Valley mindset and actually move it into the physical build out of your infrastructure and operations.
So from a hiring and culture point of view, we've started as a very innovative garage startup, like most others. And we've always had a high performance culture in the team, looking for these brilliant engineers who can solve and crack new technical problems. 3 years ago, roughly, we kind of switched gears and prepare to become an aerospace company. So we hired a lot of aerospace knowledge from the big companies like Boeing, Airbus, Rolls-Royce, etc. And the trick here was to find those 1 out of 10 people who bring the 20, 30 years experience from aerospace, but at the same time act very entrepreneurial and dynamic, because that's what we need as a startup to move fast and execute. And now I'm very proud of having a team in place of people who bring a ton of aerospace experience, 200-300 aerospace engineers and a couple of others from automotive and other backgrounds, but at the same time, a very dynamic and entrepreneurial way of working.
Hey, Jeff, I'm going to turn to you here. So as part of you're one example of recruiting from the Silicon Valley lily pad, if you will. You were formerly at Cruise, the autonomous unit of General Motors, and a separate organization, of course. Ravi and I are quite familiar with that. So what attracted you to Lilium, and what from your experiences of designing or working at a company that is bringing forth fully autonomous terrestrial transport, how do you apply that in aviation?
Yeah, so for me, it's the mission and the impact. I believe autonomous cars, electric autonomous cars, will save a lot of lives, decarbonize the world. For Lilium and the sector itself, I think there's an urgent need to decarbonize aerospace. So I'm attracted to the mission of that. Then I did a lot of research on the team and the product and actually visited Munich before I jumped in. All those questions on the technology, I diligenced. So we all understand the economics, right? If you move 6 passengers versus 4 and everything costs the same, the model looks better. But it all comes down to the team and the execution. So I got to meet not only Daniel, the other founders, but the people in charge of certification, in charge of batteries, in charge of engineering. And I thought it was, at this point, it's an execution story. So I kicked the tires on execution, and I believe we can execute.
All right. Well, I'm going to go, and I'll pass back to Robbie in a bit, but I just want to go further down the economics here. In some of my opening comments, I very naively described the use case of eVTOL as 5 times the speed. And this is versus, let's say, a cruise, for example. 5 times the speed, double the occupancy, double the price per seat. 5 times 2 times 2 is 20. You can, in theory, have an eVTOL that can generate $1 million or more of revenue per year, or 20x that of an autonomous car in some cases, or terrestrial car, while perhaps not costing 20 times to run the network. And so you might have very different payback periods and very exciting payback periods. Is what I'm saying. Bring it back to earth and tell me how you think about payback periods or total cost of ownership. And I would love either for you or Daniel to also give a similar comparison on CO2, how you measure CO2 per seat mile or per journey of equivalent versus traditional aviation, how you put some numbers behind that decarbonization strategy.
Yeah, I'll take the numbers. Daniel can take the carbon.
Thank you.
So first, we have a hybrid, so we want to have a customer-facing network, regional, and we're also would like to do sales in non-competitive settings. So logistics companies who are looking for 24-hour delivery would be a great example, where this is a better product at a better price point for certain missions. I generally agree with all of your numbers, except I don't see it as $1 million of revenue a year. I see us more than $5 million of revenue a year, and I see the payback periods in a network being approximately 2 years, right? So if you take the life cycle of one of these, there are the 8 to 10 years probably extended, payback 2 years, revenue per aircraft per year of 5 years, and those are our numbers because we have more passengers and we go longer distances. I'll let Daniel speak to the numbers on the carbon.
Let's talk carbon. I think you're muted, Daniel.
Airplanes in general are very efficient transportation systems when it comes to energy consumption. But if you look at the energy consumption per seat and compare an electric airplane to a car on the ground, the car is a bit more efficient, although the load factor that comes into play lets the airplane win. So what I want to say is if you drive an electric car with 1.5 person on board, you will have a higher energy consumption per person than having a Lilium jet, for example, with 3 or 4 people in one flight. And that is something that we've looked extensively into, making a lifetime assessment of electric cars, trains, and airplanes. And we were surprised ourselves to find that if you look at the whole lifetime from manufacturing to end of life and the service and infrastructure, that an electric aircraft like ours, an eVTOL, comes out comparable to an electric high-speed train and better than an electric car in terms of energy consumption, and that can be translated into CO2 emissions, depending on what kind of CO2 mix you have for your electricity.
Got it. Robbie?
So Daniel, Adam just said to kind of bring him back down to earth on some of that math on fast car autonomous versus eVTOL. Can I ask you the same question on the TAM side? I don't know if you saw the most recent update we published last week or not, where we had a slower build up of the TAM, but some very large numbers getting up to 2050 or so. And more interestingly, we kind of looked at what happened the last time a brand new transportation mode was introduced, whether it was the car itself in a world of horses about 100 years ago, or the airplane in a world of steamship travel about 50 years ago. Do you think that eVTOLs can be that revolutionary, that they can drive a significant increase in total vehicle miles traveled, or do you think the kind of initial few decades are going to be about taking share from passenger cars and other transportation modes?
We've seen the report, and I do think that eVTOLs, even before 2030, will take a lot of passengers from car trips, but also from train trips from different areas. The way we look at eVTOLs is that we're saying if you have a transportation system that is 5 times faster than a car, an autonomous car on the ground, but it ultimately comes at the same price per kilometer, it will capture all the regional trips in the future, a large proportion of these. And this is how we look at the market. It's going to be a very big market. We're not in the business of making detailed estimates like you do about the size of the market. Our job is to execute and build these planes and prove everybody that this is a great business and that it's super attractive for a customer to actually use it.
Got it. Another kind of big area of discussion or debate that we've had so far is about the business model itself. I think kind of you're clearly distinguishing yourself by having more of a shuttle service rather than an on-demand service. But there's also been some debate about whether you need to be fully vertically integrated up and down the stack, kind of make the aircraft and operate yourself, versus others who are only going to make the aircraft and give it to other people to operate. What are your thoughts on this? Do you think that makes a big difference to your go-to-market strategy and your chance of success?
So
yeah, go ahead, Dan.
there's, of course, as old as the industry is, there's a debate about how vertically integrated you should be, both on the manufacturing side and on the operation side. On the manufacturing side, our strategy is to stay CapEx light because there's very well-established aerospace suppliers who deliver excellent avionics and other components. You can, of course, try to redevelop all these things, but it's going to add a lot of risk to your ramp-up and manufacturing ramp-up in the market entry phase. If you look at the actual service side of things, we pursue kind of a mixed model in the early days where we are saying we're partially selling airplanes to other companies who are not competitive to our own network, because this gives us basically a predictable revenue. And then on the other side, we run our own network, which gives us more revenue per aircraft, but we have to fill the seats. So we're taking more risk on this one, which means midterm and long term, it's an advantage for us to be fully focused on the network. But very short term, we are generating predictability to some degree by also selling airplanes.
Got it. And the last one for me, for turning back to Adam, again, as the transportation analyst on the freight side, I have to ask you a cargo question as well. Again, we are very bullish in freight and cargo applications as being the early part of the curve for new technologies, whether it's autonomous trucking or EV trucking or anything like that as well. Clearly, it's a very, very important and large TAM on the freight and cargo side. Do you guys ever have any interest in tapping into that, or are you exclusively focused on passenger right now?
Yeah, no, we see the same. I think Lilium will never directly move a box. So that is with our sales side. That's really one of the key areas we see, Ravi, on the enterprise sales for two reasons. One, the push is these are better products for certain missions, particularly if you want 24-hour. The pull is all of those companies urgently need to decarbonize and are actively looking for solutions to do that. So we completely agree with your thesis, but we think that whoever it is, a UPS, a FedEx, an Amazon, the list goes on and on, they run their own fleets. So we would never try to compete and do that service, but we'd be very happy to be a provider of the platform. And we don't think that competes with what, for example, we're doing in Florida.
Got it. Adam, over to you.
Robbie, you might have noticed that in Jeffrey's background, I think it shows your apartment building there, but you probably did notice that. Nice one. We call Robbie the Oracle of Jersey City. So, all right, you have a unique attribute of being European-based, and you're doing work both with EASA and then also with the FAA with Orlando. Can you kind of compare and contrast? It seems, and I'm the wrong person to say this, but from what I'm understanding from the outside is that EASA is even in many ways a lot more stringent. I know it's not totally comparable, but because of dense urban cities in Europe and stringent in terms of flying over cities like Paris or London, where the government involvement and the regulations are on a different level. Tell us how that's an advantage and whether kind of certifying there gets you further faster with the FAA. And also, I have to ask, I'm going to forget, has your aircraft been certified, or what level of certification are you right now? Where are you in certification in either Europe or the US, if you could distinguish? Thanks.
Yeah, let me maybe start with this one. So we received in autumn last year the certification basis from EASA. This is comparable to a G01 paper in the US. To our knowledge, there's around 3 companies, I think, globally who have published, who have received something like this. So that puts us very much into the front row of companies in the sector in terms of the certification process. To your first question, yes, we are concurrently certifying with EASA and FAA. And the advantage of this is that we get a global market access from the beginning. And the problem is if you don't do that you almost certainly will have to change vehicles or even make a new design if you only certify with one and then later you go to the other. If you compare the two authorities, they've taken a slightly different approach. So EASA basically from the beginning have set a rule set which is comparable to an airliner. One of the things that stand out is the 10 to the minus 9 safety level of the aircraft, which is what you require from an airliner as well. FAA have not required this from eVTOLs yet. Maybe they do soon, I don't know. And the difference here, for example, comes out in operations. If you have a 10 to the minus 9 certification, you can basically fly over urban areas like an airliner can. Whereas if you have a lower safety level, like some helicopters with single engines, for example, have, then depending on the city and the region, you may see restrictions. You may have to follow a river to access the city, and you may not be allowed to just fly anywhere. So there may be implications on the operational side, but you can't generalize these implications in a sense that each region and each airspace authority, like FAA or the European authorities, react differently on the safety level of these vehicles.
Great. Thanks for elaborating there. A couple questions from the audience. How long have you been testing full scale and full weight? And additionally, you've hired several execs with Airbus manufacturing experience. How are you preparing for manufacturing? What's your approach to scaling up in manufacturing?
So on the first one, we've had a 2-seater and a 5-seater, but if we take the 5-seater, we've tested this one in full scale and full weight for around 9 months in 2019 in an extensive flight test campaign, which was very successful, basically doing all the maneuvers which we wanted to do, from the vertical takeoff to the forward flight, circles, climb, descent, but also things like engine or actuator failures. We've tested on this aircraft in flight. To your second question on the manufacturing side, the way we're preparing is very classic like other aerospace companies. If you want to certify an aircraft, you have to produce your prototype for certification, the airplane you use to demonstrate you are compliant with all the requirements. This airplane already has to be produced in the manufacturing processes and traceability of a full aerospace supply chain, which means already now we are building up our serial manufacturing lines and processes. So we're next year able to produce a certification prototype, which we then use for the certification flight test campaign. And there's a big difference between a demonstrator aircraft, like the airplanes us and others are flying right now. These fly and look like a product, but they don't have the aerospace grade production and supply chain and quality management in the background. So all of us basically have to set up this entire aerospace process at first and establish the traceability, the quality management, and then make an actual aerospace grade airplane and use these for the certification. So it will be a big milestone for us next year when we're actually building an aerospace grade aircraft. And to give you an idea, the difference is that we needed around 25, 30 engineers to make the demonstrator aircraft. You need around 400, 500 engineers to make an actual aerospace grade airplane. And they look the same from outside.
Got it. Thanks for that distinguishment. I got a question on your partnerships. And in your presentation materials, you have, you distinguish between infrastructure and training partners, but also, aerospace suppliers and development partners. And including in that second list, we have Palantir. Can you give us a sense, because the question was specifically, tell us about the Palantir relationship. How is that working? And for the infrastructure partners, it does seem that this is a very important skill set that, irrespective of what form factor you take, is a very important enabling skill and part of the equation at all phases. Tell us about how you differentiate there on the infrastructure side.
Sure. We're super excited about Palantir. They have deep experience in aerospace. So, for example, Tom Enders brought them into Airbus, and he would tell you that they helped them supply chain, the manufacturing, cutting time, saving hundreds of millions of euros, as well as they built the digital network that is used by over 100 airlines. So for us, we're already working with them on the supply chain and the manufacturing side. As we get deeper into our digital network, we see a similar path, but they're super experienced in aerospace, very high value, great partnership. On infrastructure, our philosophy is we should control our infrastructure for the first couple of years. Ferrovial is both our partner and an investor, so we view that as a strategic relationship. They have a balance sheet as well as expertise in permitting, running airports, so they can help us tremendously, both building these but running them efficiently. And the way that works is they're building them, owning them, and then we repay them through landing fees and operations. So we're really partnering and betting on this industry growing and decades of working together.
Great. We're coming up on time, so I just want to give you a couple of rapid fire questions. Daniel, I'm going to focus on you here. What's your favorite plane ever in the history of aviation?
I think the Concorde.
That's a beautiful one. Okay, yeah, we need to bring that back. That's a different topic, hypersonic. We'll have a summit there, and you can talk about that. You're a pilot. You've been a pilot since I think you were about 7 years old or something. Actually, how old were you when you first flew?
I was 14 when I flew a first airplane alone. That was a glider. And surprisingly, that's legal in Germany.
We won't go into what's legal in Germany, but it sounds like an exciting place. What's your favorite place to fly?
I'm not flying these days, to be honest. I don't have time to fly. But if I could, I love mountains. It's more interesting. That
also sounds a bit challenging. All right, so we're going to leave it there then. Daniel and Jeffrey, thanks so much for joining us. Robbie, thanks for your questions. And this concludes the Lilium presentation. Thanks, everybody.